Why does ice float? The secret of density, and why it keeps fish alive in winter. Here's a question that sounds simple but has a jaw-dropping answer. Why does ice float on water? I mean, ice is water. It's the exact same stuff, just colder. So why doesn't it sink? The answer is density. And it literally saves millions of fish every winter. Science fact: ice is about 9% less dense than liquid water, 917 kilograms per cubic meter vs 1000 kilograms per cubic meter. Which is why it floats and why bottles crack in the freezer. Density is simply mass divided by volume. How much stuff is packed into a given space. Rho equals m divided by v, that's it. Now water is weird. Most substances get denser when they freeze, molecules pack tighter. But water does the opposite. When it freezes, water molecules form a hexagonal crystal lattice, and that structure actually spreads the molecules out, creating more space between them. Result: ice at 0 degrees Celsius has a density of 917 kilograms per cubic meter. Liquid water at 0 degrees Celsius, 1000 kilograms per cubic meter. Ice is 9% lighter per unit volume, so it floats. Now here's where it gets beautiful and important. Because ice floats, lakes and ponds freeze from the top down, not bottom up. That floating ice layer acts like a blanket, insulating the water below. Fish, plants, bacteria, entire ecosystems survive under that icy lid. In the oceans, density also drives something called stratification, layers of water with different densities that almost never mix. Warm, less dense water sits on top. Cold, saltier, denser water sits below. This separation affects nutrient cycling, marine life distribution, and even climate patterns. Density differences between warm equatorial air and cold polar air, that drives wind. The weather outside your window right now. Density at work, so next time you drop ice into your drink, remember. You're watching one of nature's most important accidents, a substance that defies the rules, and in doing so, makes life on Earth possible. Key takeaway: Rho equals m, v. Density differences drive stratification in oceans, lakes, and the atmosphere. And ice floating, that's not just physics, that's survival. For your homework, think about this. How does water density change with salinity? And why does that matter for ocean circulation? We'll get into it next class.